Guys, in this video I'm going to discuss one more problem for second order model. So before going to second order model problem, I'm just summarizing quickly about how we solved the first order RSM. This is a first order RSM model or a problem. Mainly they have two factors, one is temperature and another is reaction time. Current running condition is 35 minutes time and 155 degree Fahrenheit is the operating temperature. For that they got 40% of yield. So they want to increase, the experimenter wants to increase the yield. So they are proposing for steepest ascent or maximizing the yield like that. So in that case, so what they done, the current operating condition they done 5 repetitions or 5 observation they done, and for that they identified the response value. And since by adding center point, as I said in steepest ascent, uniform interval like 35 and 150 means consider as a 5. So in 30 and 40 for time, and for temperature instead of 155, 150 and also 160. But with these four values, they done an experiment and found out the responses. Once they calculate the responses, they need to prepare the first order model. So in the first order model, this is the first order model. So beta 0 plus beta x1 plus beta x2 plus dot dot dot. In that beta 0, beta 1, beta 2 they need to calculate. Beta 1 is calculated by here, average of all the y responses, like 9 values are there in the table. The response average is considered as a beta 0, and beta 1, beta 2 is factor x1's x1 for x1 we have a beta 1, for factor x2 we have a beta 2. Beta 1 in the sense 1 by 2 of the effect of x1. Here effect of x1 we can able to calculate like a high level of high level of x1 minus low level of x1, and here also high level of x2 and low level of x2. This values are from the table. By doing that we can able to calculate the beta 1 and beta 2. Substitute that, we can able to get this first order model. So now we need to understand what is the first order model is fit or not. For that we need to estimate the error, and we need to estimate the test of interaction, and we need to calculate the test of quadratic effect. So how to calculate the estimate the error? So error time can be calculated from this. All these 5, the first 5 values are in the current operating condition like 35 and 155. 5 repetition they done. The each response is square summation minus. Then alternatively they found factorial points like 4 points, right? That sum is not square, individual sums whole square divided by totally you have a this all together 5 value, and all together you have a value and another 4, so totally 5 values divided by n minus 1, totally n minus 1 minus, so n minus 1 4. With that we could be able to calculate the mean square error. Once we calculate the mean square error, we need to go for a test of interaction, whether interaction is there or not, whether that interaction is significant or not. So hypothesis we know beta 1 2 equal to 0, beta 1 2 not equal to 0. That's it. So how to calculate the interaction? Interaction in the sense 2 corner points 39.3 and 41.5 and 40 and 40.9. This interaction, finding the average 1 by 2 of average of this and this will give us some value. That value is the interaction value. We need to know whether this minus 0.025 is significant or not. How to know? We need to calculate the F value. So how to calculate the F value? For F value calculation, we need what are the term? We need a mean square error value, sum of square value, and degrees of freedom. So for degrees of freedom for interaction, since 2 factor, degrees of freedom is 1. If mean square error in the sense we have a degree 5 minus 1 4, degrees of freedom 4. So here sums of squares, this 0 minus 0.1. So we need to calculate from this. For example, in this bracket, like a contrast value 40.5 plus 39.3 minus 40.9 minus 40. This value is minus 0.1. Okay. So that is the value we are substituting in sums of squares of x1, x2. Degrees of freedom is 4 divided by mean square error, which is calculated in the step 1. The F value is 0.058. Definitely it is very low, because we know F value means it should be 30, 10, 12, something like that. Comparatively is very low. Or we can able to refer with these degrees of freedom in the F table also, we can say it's significantly lower. Then next step is test of quadratic effect. For calculating the quadratic effect, we need to calculate beta 11 plus beta 12. So for calculate beta 11 plus beta 12, we need responses of factorial points minus response of the central point. So response of factorial point means 1, 2, 3, 4. Each has some having some responses. Average minus center. We done 5 repetitions. That average. By doing that, we will be getting some value minus 0.035. Whether this value is significant or not, we need to calculate. Then we need to go for f calculation. If f value equal to sums of squares of pure quadratic divided by error square, mean square error first we calculated. How to calculate sums of squares of pure quadratic in this sense? This is the equation where n of nc equal to n of means number of observation in factorial points, and nc means number of observation in central point. So here is 4 and here is 5. This is the value we know. With that we can able to calculate the sums of squares of quadratic, pure quadratic, divided by that error term, then f value. So this f value also very lower comparing with the f critical value. So with this we could be able to frame this table. So what are all the values we have? We calculated this value, we calculated this value, we calculated, and pure error also we know. With that we can able to calculate the residual value. So once we know all this value, total sums of squares of total we can able to calculate by this method, like average of all the responses, sums of squares of all the responses minus individuals values whole square divided by 9. We will be getting SS total. Once we know the SS total, subtracting that, we will be getting the sums of squares of model. So once we have this value and degrees of freedom, we can able to calculate the mean square value. Once we know the mean square value and also residual value, once we have the residual, we can able to calculate that. This ratio will give us, this ratio means what? 1.4125 divided by 0.02953 will give us the f value. This f value we have to compare with the f critical value, means from the table. If significant lesser means we can say the model is fit. Then we need to say whether beta 1 and beta 2 individually we calculated some value, what value 0.775 and 0.325, right? So whether that values are significant or not, we need to consider, means we need to understand, we need to find the variation for beta I. It may be beta 1, beta 2. We need to, how? Mean square error divided by 4. So here variation sums of squares means root of mean square error divided by 4. 0.0430 divided by 4 will be 0.1. This 0.1 we need to compare with the beta 1 and beta 2. Beta 1 is 0.775. So it's very big difference are there, and beta 2 also bigger. So we can say that but both regression coefficient, that is this, and are largely related to the standard error which we are getting. At this point we have no reason to question the adequacy. So first order model is fine. So once we done, we need to go for optimization process. In that, initial operating condition is what? Like a 35 and 155. Origin we can say it's 0, 0. Then next is delta, changes in the value. So how much value we need to change for the x1 and x2? Since it's linearly varying, normal in the sense we need to calculate the slope. So for calculating slope, we need x1 and x2. x1 is varying uniform. Delta x1 equal to 1. 5 steps are 5. Using the previous relationship in the first page of this problem we said now. So that summation 1 minus 5 divided by summation 1 minus epsilon 1 minus 35 divided by 5, and epsilon 2 minus 155 by 5, right? With that we can able to say that this is 1 and this is 0.42. So 0.42, the step size is 5. So how much is there? How much percentage is that? 2 times, right? Yes or no? 2 times are there. So this is 1, and we have to multiply 5 interval into 0.42. 5 into 0.42 will be giving 2.1. So closer to step size is 2. So this is 2. So initially for x1, since it's 1, we are going with the 5. But x2, delta x2 is slope value that is calculated from the ratio between the beta 2 divided by beta 1. So that is coming 0.42. 0.42 from the usual interval, uniform interval is 5. 5 into 0.42 is 2.1. Instead of 2.1, I am giving like a 2. So in changes. Step size will be 5 for x1 and 2 for x2. X2 in the sense original one 0.2 means 40 and 157. Then 45 plus 157 plus 2 159. 45 plus 5 50. 159 plus 2 161. Like that we need to continuously we need to do. Then same way we need to perform the experiment also and find out the responses. Certain point of time the responses started decreasing, so by putting the graph we can able to say that it's increasing, suddenly started decreasing, so we can say this is the optimal point. So from this to this optimal. Again we may go, if we want to reconfirm this point is optimal or not, assume this is the central point and here we can able to repeat the 5 times or 2 times or 3 times. You consider this is the factorial point, again perform the same methodology for solving the what to say first order RSM model. So with that way also we can perform. Again see the current operating condition 85 and 175 also they done 5 repetition and found out the values. Same procedure like calculating the beta 0, beta 1, beta 2, interaction, quadratic effect, whether it's significant or not, everything calculated and understood that. Again they made a one more table, both are telling significant or not. Okay, so this is how we solve the first order model. Okay, in this problem I am going to discuss about second order model. That explanation of stories I am not giving much, so directly I am jumping into second order model problem. Okay, so here the problem is response surface for certain manufacturing process was defined by the given equation. So in here directly they are giving the equation. Maybe in exams you guys also will be getting similar kind of equation, second order equation, because the square terms are there, second order, or you may be given with the first order model with the beta 0, beta 1, beta 2 alone. In that sense we need to go with the first order model solving procedure, but here it is directly they given response surface equation. Determine the approximate optimal operating point using the method of steepest ascent. Starting point of result should be x1 equal to 2, x2. So current operating condition is they telling x1 equal to 2, x2 equal to 3, and step size uniformly how much they want to increase, 4. So this is the operating, this is the equation, z equal to 17x1 plus 27x2 minus x1 whole square minus 0.9 x2 whole square. So remember, in this kind of problem solving you have to be very careful about signs and points or squares and all. So step size is also given 4. So current operating condition x1 equal to 2, x2 equal to 3. See, in this we need to substitute, in this equation we need to substitute the x1 value, x2 value. So they are substituting x1 as a 2, x2 equal to 3, and they are finding this is the what output. We can say that output of this response is 102.9 for the current operating condition. So what they need to do, they need to go for optimizing. That means they need to find new x1 x2. In the first order also we calculated the x1 x2, and then second x1 x2, x1 x2 continuously till we are getting the better responses. Until that point we need to calculate, after that we have to stop. So here also the same procedure, we need to calculate the new x1 x2. So how to calculate? We need to find the gradient of x1 and the gradient of x2. What is the equation to calculate the gradient of x1? Equal to g1 dot p g2 dot p. So here g1 dot p gradient of a point in the sense like a differentiation of delta x1 delta z response divided by x1 and first order differential. So if you differentiate this, what you will be getting, x1 will be 0 and x2 will be also eliminated because we are doing with the x1. So this is eliminated here, 2x1, and this 2 term will be eliminated. In terms of gradient x2, in the sense this term eliminated, this term also eliminated. Then 27 minus 2 times the 0.9, 1.8 x2. So gradient of x1 we calculated, gradient x2 also we calculated. Then we need to calculate the magnitude value. So why we need to calculate the magnitude value? In the sense, in order to find the new coordinates x1 and x2, we need to consider the current coordinate plus step size plus the gradient value divided by m. So this is the m1 or m2. This is the equation for calculating the new coordinate. So x1 we know, x2 also we know, step size c also we know, it is given like a 4. gp1 we know, we calculated the gp1 like this, differentiating this equation we get 70 minus 2x1 and 27 minus 1.8x2. So then we need to calculate the m value. How to calculate the m value? The m value can be calculated using this. M value equal to square root of gp1 whole square plus gp2 whole square. So gp1 value 17 minus 2x, x1 we are substituting the current value, we got 13, and for g2 27 minus 1.8 x2 will be substituted like a 3, so 21.6. So square root of this will be giving us 25.2. Square root of this whole square plus this whole square, okay, that will be giving m. So once we know the m value, substitute the m value here. Once you substitute the m value, we know the g value, we know the step size, and we also know the current operating condition x1, x2. We will be getting the new x1 and x2, that is x1 prime and x2 prime. So now we have x1 prime and x2 prime. What is the next step? This new x1 and x2 value we need to substitute in the original equation and to find the response. The response is 188.981. So what was our previous response? It's around 1 or 2. But what is the current response? It is with the new coordinates we are getting 188.981. So what is there? Improvement is there. Then what to do? We need to go by finding another x1 and x2 value. For that again we need to have the gp1 and gp2. In this x1 and x2 we should not substitute the original one. What we calculated now, that new x1 x2, that is what x1 is what now, previously 2 3, but now what 4.063 6.43. So x1 x2, this x1 x2 if you are substituting here, you will be getting the gp1 gp2 here, and m also you can able to calculate with this value. C step size is same, but here x1 x2 you need to substitute this 4.063 and 6.43. By substituting that, for the new x1 x2 we are getting the 245.3 as a response. Previous step 188, next step is 245. What needs to be that? Since increasing, one more x1 and x2 we need to calculate. Yes, how to find that new x1 x2? This is the procedure. So new x1 x2 we calculated and substitute that value. Again gp1 gp2 continuous, the same procedure we need to repeat, again increasing. Then at one point of time we can able to see that point of decrement 269. That means continuously we got increment, but finally initially with the current operating condition 2,3 1 or 2.9. For second x1 x2 we got 188. Third one for x1 x2 we got 245. Fourth one we got 272, but for the next step we got 269. Even if you do one more time, this may go down only. So from this current operating condition, means this is 1 or 2, then again 188, again 245, again 272 and 269. So from here to here we are moving, means this is the current operating condition 2,2, and the final optimal coordinate value is 9.412 and 17.13. So this is the optimal condition or operating condition or level we can able to get a better response. Okay, this is the second order model. Okay, I hope you guys understood. Again I am repeating the process. What are the steps we need to do? We need to calculate, first we need to substitute the x1 and x2 values in the given second order model, and we need to calculate the response value. That is what we done. Just a second. So step size given, equation given, x1 and x2 value given in the problem itself. C also, step size is what? C. This is C. This is also given. Then substituting the 2,3, then we will be getting this equation, and 1 or 2.9 is the response for the current operating condition. Then we need to play with the coordinates so that we need to know whether improvement is there or not. So I need to calculate the new coordinates for instead of 2 comma 3 we need to find the new coordinate for x1 and x2. What is the equation for calculating the new coordinate x1 and x2? x1 plus step size into gp1 divided by m. So here m is the magnitude value, gp1 how to calculate, step size is given, x1 also we know, similarly x2 we know, step size we know, m we need to calculate and gp2 we need to calculate. So how to calculate the gp1? So we need to do the differentiation. gp1 is what? Gradient 1, gradient for parameter 1 and gradient for parameter 2. So for parameter 1 in the sense x1 means differentiating this with x1 means this term will be eliminated, x2 terms will be eliminated, this term also eliminated, only we will be having 17x1 minus x1 whole square. Differentiate that in the sense 17 and minus 2x1. Then similarly here 27 minus 2 into 0.9, 18, 1.8 x2. So once we know the gp1 value, in this we need to substitute the what is the x1 value and x2 value. gp1 is 13, gp2 is 21.6. Squares of this and square root of this will be giving the magnitude. Substituting this magnitude and gp1 value, will be getting new coordinates for x1 and x2. So what we need to do with this new coordinates, we need to substitute this x1 x2 in the original equation and we need to find the yield response value. The response values got increased or decreased? Increased. So still there is a space to improvement. So again we need to calculate one more x1 and x2. Same procedure, one more x1 x2 in the sense here x1 x2 which is we calculated now, we have to substitute. We can calculate this gp1 and magnitude value, c value same. With this new coordinates, again you calculate the response. These steps needs to be repeated n number of time until we reach the responses started decreasing trend. So here in this step 245, next step is 272, next step is 272, then 269, then it's a decreasing trend. So we can able to wind up. Then we can make this comparison up to here increment, after that it's decreasing, right? So once it's decreasing in the sense, no need to do. So this is the better operating condition, like that we can able to conclude. Okay. So this is what the second order model. So first order model, second order model is very, very important for our response surface method. Okay. Thank you.